Hello everyone, welcome to linear regression session. In this session, we will discuss all about linear regressions. So I just discuss what are the introduction part of the linear regressions, like what are the concepts which comes under the linear regression. I will just discuss. So first of all, let's go for the what is linear regression. So basically, the linear regressions is a statistical method for modeling the relationship between the dependent variable and one or independent variable. Like if we'll just go for this data set, this one is the data set. If we'll just go for this data set, the weight which will be behave as a independent variable and the height which will be behave as a dependent variable. So here in this linear regression, we have to just visualize one data and that data set is here. So let's visualize the weight and height, okay, according to this data set. So this is the visualization diagram where height is in the x-axis and the weight is in the y-axis. So here he just taking that part. So here weight is the dependent part. He's just taking weight is the dependent part and height is the independent part. Right? This one is the y-axis and this one is the x-axis. So here the data point which is written like this. And here we have to what? We have to just create one line with the help of the y equal to mx plus c. Y equal to mx plus c. So here the point is what, like this one is the equation and with help of this equation we will just draw this line. Here our goal is what? To draw this line which will be fitted in the best way according to the data points fitted. These all are the data points. These all are the data points. So based on this value, the data point which is fitted. Let's go for the next part. That one is the type of linear regressions. There is a 4 types of linear regression. One is the simple linear regression, multilinear regressions, and polynomial regressions, and then logistical regressions. So if we'll just go for the simple linear regressions, so this one is a simple linear regression. In simple linear regression, so there is a one independent variable, and there is a one dependent variable. So it means what's only single independent variables are there. So based on it, we are just saying that there is a simple linear regression concept. And if we just go for that multilinear regression, think that you in your data set, there is a multiple independent features are available. X1, X2, X3, and then at the end, the target values here. So as the multiple independent variable which is present in your data set, so we will just call it as a multilinear regression. So this number of line is nothing but what he just trying to just draw the best fit line. Let's go for the third one, the polynomial regression. It's not sure that every time the line will be what in the straight line. So there is a chances will be there, the data point which will be split like this, and our goal is what? To fit that line in the best way. So for that fitting the best line, so we have to just bend that line. So that's why you are just moving towards the polynomial regression. And this is all about what you can just go for also this type of data set. And the last one is nothing but the logistic regression part. The logistic regression is nothing but all about the classification problem. So as you already know that the regression and classification, the regression is all about the real value. Means the target part will be this part. The target part will be what? The target part will be the continuous, or else you can say the real value or the real value. Like you can just take an example of student percentage, right? Or you can just take an example of height and weight. According to the height, so there will be weight measurement. Okay, so if the, or else if the weight will be 50, your target will be what height? The height will be maybe the 150 to 155 centimeter. So this is what the regression part. But what about the classification part? Whether this person is eligible for that driving license? Yes. If that person is more than 18 years, then it will be possible. He is just eligible that criteria. If that person which is below that 80 year, then that person is not eligible. If it will be true, then it will be considered as a what? If it will be false, then it will be considered as a zero. So hence, so this is what classification problem. Or else you can just go through another example. There is a person who is just suffering from the heart problem. And if that person who is just visiting one medical and he just, the doctor considered that, okay, so based on that symptom, so the person who is not suffering from the heart disease, it means what? This will be considered as the zero. So based on the symptoms, the person who is not suffering from the heart disease, and based on the symptoms, okay, so that person is suffering from the heart disease, that will be one. It means what? So there will be categorical type is coming. So if you will just represent one of the graph, classification graph, so here the upper part is nothing but what? So here the upper part, this upper part is nothing but what? You can say that the heart patients are there, and the lower part is nothing but there is a no heart patients which is not suffering from the heart disease. Clear? So here these are the what? The data point which will be split like this. Right? The data point which will be split like this. So this is the classification part. So here in the regression part, so the logistic regression which will be classified, and the diagram is looking like this. Now the next one is what? The assumption. What are the assumptions which is comes under the linear regressions? The linearity, the independence, the homoscedasticity, and the normality, and the no multicollinearity. So all these are the one of the most important concept. So it will take some time to explain. So in the next video, I will explain. Okay, so whenever the concept will come, then I will explain it. Let's go for the next concept. That one is the performance matrix. Like if we'll just build one model, if we'll just successfully build one model, linear regression model. So after that, we will verify whether that model is good or bad. So with the help of the performance matrix, you will just verify. Like if you will just check your performance, then you will just go for your what career mark. So what exactly you are just scoring the percentage in class 10? What exactly you are just scoring the percentage in class 12? So based on it, so you are just checking your performance. Like companies also checking your performance. Similarly, how you will just check the performance of the model? We can just go through that performance matrix of the linear regressions. So this is the what. So these are the five things are there. So which will be what? We'll just check out like these metrics which will evaluate how well the linear regression model fit the data. They measure the proportion of the variance in the dependent variable explained by the independent variable. What is R square? What is adjusted R square value are there? What are the coefficient of determination value are there? What are the F statistics value are there? What are the P statistics P value will be there? So this is the things. Next performance metrics like error matrix. Like we will just find out the error. Like what is the mean square error? Okay, so this will be help you. Like what exactly error means what? So whatever data point is splitted, okay, if the data point is splitted and we are just drawing one regression line. So what exactly? This one is the actual value and this regression line is nothing but the predicted value. What exactly the gap in between this actual and the predicted value? This part is nothing but the error part. And with the help of the mean square error, we'll just calculate that part. With help of the mean absolute error, we'll just calculate that part. Then RMSE. Then all these things are which is coming under the regression concept, which will be help you out to find out the error. But there is a certain of advantages and disadvantages are there to use all these things. And then next jump to the next part, and that one is the residual matrix. So this is also one performance matrix. So these metrics analyze the residual error to check the pattern, outlier, or the non-randomness. They help to evaluate the model assumption and the identify the potential issues. As I just discussed, assumptions part. So here it will be help you out. So the residual sum of the square, the residual mean square, the residual standard error, then the mean square logarithmic error. So as this course will be enhanced, then this topic will be covered as well. Clear? And now let's go for the next part, and that one is the coefficient of matrix. So these metrics evaluate the significance and the reliability of the model coefficient, and that one slope and intercept. So here the coefficient of variations are there. Then the next part is the standard error of the coefficient, P statistics and P value of the coefficient. So please, this one is nothing but the like my error, typing error. So just ignore this part. Okay. So 2, 3 parts. So there is a total 4 parties there. There is a total 4 parties coming. So these are the things. Now let's go for the optimization technique. What exactly the optimization technique is it? The optimization technique which will be used to find out the best solution among a set of the possible solution and given a specific objective function or the criterion. Like if you have to enhance your model performance, then you can also take an help of the optimization technique. So these are the list of the optimization techniques are there. Ordinary least square, gradient descent, stochastic gradient descent, ridge regression, lasso regression, elastic net regression, conjugate gradient, then Newton method, and then LM algorithm, Bayesian optimization, simulated annealing, and genetic algorithm. So these are the algorithms. So we will just cover so for the upcoming session. So hence, so these are the introduction part of the linear regression part. So in the next class only, so we will go for the what exactly the linear regression and all these things only comes under like the linear regressions, and I will explain each and everything, whatever things I just show you in a slide, right? So for this session, so this much. So thank you everyone. So subscribe to the channel, like and share. And if you are having some doubt, you can just keep comment. Okay. So I will just try to just respond to your comment and I will just